If you are building a service that processes payments, your software architecture has a lot of requirements. Not only do you need to be highly available, consistent, and fast, you need to be PCI compliant. In this episode, we explore the infrastructure of Stripe with Evan Broder, who has been with the company for 5 years. Stripe started as a small payments company catering to developers with a monolithic code base. Some of these aspects of Stripe have changed, and others have stayed the same. In our last episode, we covered how observability works at Stripe. In this episode, we explore some of the things that are being observed, the actual infrastructure itself, and how different engineers are organized around managing that infrastructure. In tomorrow's episode, we'll talk to Michael Manapat about Stripe's machine learning pipeline for detecting and preventing fraudulent transactions. There is some overlap between the infrastructure episode that is today and the machine learning episode that is tomorrow, so I hope you can learn from those tie-ins. Throughout these episodes about Stripe, you will get a sense for how the engineering culture at Stripe works, and we hope to do more of these types of series in the future, these experimental series with some degree of continuity. Please give us some feedback for what you think of this format. Send us an email, join the Slack group, fill out our new listener survey. All of these things are available on softwareengineeringdaily.com, and they help us tremendously because they help us cater to the listener, which is the thing that we want to optimize for. I hope you enjoy this episode. Life is too short to have a job that you don't enjoy. If you don't like your job, go to hired.com/sedaily. Hired makes finding a new job enjoyable, and Hired will connect you with a talent advocate that will walk you through the process of finding a better job. It's like a personal concierge for finding a job. Maybe you want more flexible hours or more money or remote work. Maybe you want to work at Facebook or Uber or Stripe or some of the other top companies that are desperately looking for engineers on Hired. You deserve a job that you enjoy because you're someone who spends their spare time listening to a software engineering podcast. Clearly, you're passionate about software, so it's definitely possible to find a job that you enjoy. Check out hired.com/sedaily to get a special offer for Software Engineering Daily listeners. A $1,000 signing bonus from Hired when you find that great job that gives you respect and salary that you deserve as a great engineer. I love Hired because it puts more power in the hands of engineers. Go to hired.com/sedaily to get advantage of that special offer. And thanks to Hired for being a continued long-time sponsor of Software Engineering Daily. Evan Broder works on infrastructure at Stripe. Evan, welcome to Software Engineering Daily.
Thanks for having me.
In this episode, I want to talk about the infrastructure of Stripe. So why don't we start there? Give me a high-level overview of the Stripe infrastructure.
Yeah, sure. So we're primarily a Ruby shop. We've written most of our code and infrastructure in Ruby. We're starting to use a little bit of Go for some of the infrastructure components. But our stack is, the basics are relatively straightforward. It's pretty standard web tier load balancer, main application, some fan out to some auxiliary services, databases on the back end. Nothing too unusual or exotic.
Most of the companies I talk to are on AWS. They might use Docker containers. They might use something like Kubernetes to orchestrate those Docker containers, and they put services inside them. Is that similar to your architecture?
So there's some that's in common with that, but I think there's also some that's different. We are using AWS pretty much exclusively. But we've mostly not gone down the sort of really aggressive microservice Kubernetes route yet. For us, one of the big things that you really need in order for microservices to work well is you need to have good failure isolation. You need to be able to have those components fail independently and have that be okay. For us, the stuff that's sort of really important to us, the kind of the core service offerings, are sufficiently interconnected that it's really hard to make them fail independently, right? We actually did at one point experiment with pulling some things out into isolated services And what we found is that when those services went down, there wasn't sort of a reasonable way for us to respond gracefully. Like if we pull out foreign exchange and currency conversions into an isolated service, like that service can't go down, or we just can't, we can't run charges in different currencies anymore. And so for most of our infrastructure, what we found is that there's enough sort of fundamental interlinkage that it doesn't make a ton of sense to try and break it up too extensively.
Are you saying it's a monolithic architecture?
It is sort of tending more towards monolith than not.
From what I know about Stripe, you have the completely synchronized critical path of the application in a monolith, and then some of the auxiliary things are in services. Would you say that's accurate?
Yeah, that's probably pretty accurate. There are some things that we've been able to pull out in cases where we do feel like there is real failure isolation. I think that our fraud evaluation stuff, for example, is an example of that, where the type of failures that it experiences are very different from the rest of the API. Because one of the things that it does is it basically pulls in a ton of information, and so it has dependencies on all those information sources that maybe the core of our API doesn't. And so the ways in which it fails may be slightly different, and our options for handling those failures are different as well, right? We can fall back on some very simple heuristic in the worst case, or the simplest heuristic, which is just don't do fraud detection. Not that we want to do that, but we have a lot more flexibility with certain aspects of the application. But in general, most of the application is pretty monolithic.
Later today, I'll be talking to Michael Manapat, who works on data science and machine learning at Stripe. Can you describe the interface between this core infrastructure that I'm talking about with you and the machine learning infrastructure that I'll be talking about with him?
Sure. So when a new transaction comes into the Stripe API, the core API component itself will kind of serialize the information about the charge. So what's the amount, what Stripe user is it on behalf of, maybe some information about the some of the information that we use to determine whether something is likely fraudulent, IP address, other pieces of information like that. And it passes it off to the fraud service, which makes sort of serializes that as kind of a bundle of information. The fraud service may pull in other information like context or information about recent transactions, or sort of whatever else we think is relevant to making that determination, and it makes the call and sends it back. And so that piece is kind of isolated.
I've done a few shows with people from Smite, which is a company that fights bad actors online, and Smite is ex-Instagram people. And they talked about how in the early days of Instagram, there was basically anti-fraud code in the core monolith of Instagram. You'd have these regular expression checks where you'd see, is the email address coming from .ru domain? Is it a Russian domain? Maybe that's more likely to be fraud. And this was in the core monolith, and they stripped that out into another service as a very early thing they did once Facebook acquired Instagram. Was it a similar story with Stripe, where once the product got some traction, it was very quickly stripped out of the core monolith, this functionality of fraud detection or bad actor detection, because this is so core to the product that you really want to strip it out and give an entire team domain responsibility for dealing with this fraud detection, bad actor detection?
For the fraud detection system in particular, I think that was something that we realized as we were starting to build it out, that the failure domains were going to be very different, and that that the inputs into it were going to be different, and so the degree of isolation that we could look for was also different. That was actually a case where when we first started doing that fraud detection, that we did it kind of outside of the core API service.
I see. So because Stripe was rolled out in such a deterministic fashion where the early developers who were using Stripe, you knew exactly who they were. I think the beta release process for people who could use Stripe was very slow, and so you could take a very deterministic approach rather than just opening it up to everybody, like Instagram, was open to everybody, and they had this huge volume of stuff to deal with. So with Stripe, you could really take a more deterministic fashion, a slow fashion to developing this machine learning service.
I think it's less that we didn't think about fraud in the earlier days of Stripe, and more. I mean, we certainly spent plenty of time thinking about fraud, but I think there was some sort of graduation in terms of how we approached it. I think the early days of Stripe were a much less sophisticated detection system. Simple rules. If you see this card number X number of times over Y number of seconds, as Stripe grew and as the business grew and as the team grew, we started to move sort of out of that manual rule-based approach into more of a machine learning driven model-based design. And that was kind of the point at which we ended up building outside of the core service.
There are some services, there are some communications between the monolith and the different services. We did a show recently about Envoy, which is a service standardization tool from Lyft. Do you have any standardization among the different services?
We have it for some aspects of our inter-service communication. And there are certainly cases where we've gone back and forth on what we think the best approach is. For the most part, we haven't done a particularly rigorous restriction on the protocol that services communicate over. It's mostly HTTP, but the details of what that looks like, is it RESTful, is it RPC style, is it JSON encoded, is it Thrift encoded, is it something else? We've mostly not really set any hard standards around. We do have a lot of standards around things like how we do service discovery. That's something that's pretty standardized across our infrastructure. We've been using Consul for the past couple of years. And a lot of aspects of our services, like how code deploys work or how our CI infrastructure works or how our build works, are all pretty well standardized. And so we've looked for standardization where we think that there are sort of clear and obvious, to our perspective, right answers.
Yeah.
But I think there are other cases where that's less clear, and we've been a little bit less prescriptive about that.
We've had some shows recently where we discussed this service versioning question. Essentially, the question is, you've got a microservice, you have a new version of the microservice that you want to update, but older consumers of that microservice may not be able to consume the updated version because they haven't updated their API or their API requests to it. So you have this situation where maybe you want to stand up a new version of the service and leave the old one running. Some people say you should never do this API service versioning. Other people say that you should. For a external developer-facing company like Twilio, for example, Twilio needs to version it because they have no choice. They can't do internal synchronization of every consumer of the API. But at Stripe, you have more control over the consumers of it maybe. What do you think of the question of service versioning?
There are a lot of ways to make changes to an API that are sort of backwards compatible, right? You can add new interfaces, you can return new types, you can add new fields. And for the most part, I think that we've generally found that gives us enough leverage to kind of move internal consumers forward without needing to actually introduce new versions in any kind of hard sense. And because our application is relatively monolithic, there's sort of fewer edges that we have to deal with. It's pretty feasible to make a change to the API, chase down the consumers of that API, get them up to date, and then drop support for the old thing. And because it's not that there's, one monolith we have to deal with. There's probably, maybe any service has a half dozen consumers or something like that. But that's still a pretty manageable number. And from a engineering philosophy perspective, we're really big believers in not letting your service boundaries sort of overly dictate your work boundaries. Like, just because things exist on opposite sides of a service boundary doesn't mean that the person on one side shouldn't be able to go work on the thing on the other side. And so I think if somebody needs to make a change to their API, and that's going to affect consumers of that API internally, then as an engineering organization, we want those people to be empowered to go and work on and kind of help fix the other side of the API as well.
Release the Kraken. Get Kraken, that is. Are you tired of feeling like you're sailing the stormy seas because you have a clunky, old Git user interface? Unleash the beast that is Axosoft's Git Kraken, voted 2017's most popular Git GUI for Windows, Mac, and Linux. GitKraken is designed to make you a more productive Git user. The app offers efficiency, elegance, and reliability. The UI equips you with a visual understanding of your branching, merging, and commit history, and features multiple profile support, one-click undo and redo, a built-in merge tool, and fast search. Run the installer, open the app, and set sail with GitKraken. Easily set up integrations with GitHub, GitHub Enterprise, Bitbucket, and GitLab. That's one high-performance sea monster. Visualize your version control and code on into the sunset, sailors. Visit gitkraken.com/sedaily and use promo code SEDaily to get $10 off GitKraken Pro. Are there any core engineering principles that you try to get people who work at Stripe to adopt?
So I think that one of the big things that's always been really important to us is this idea of sort of taking responsibility for the entirety of the project that you're working on, which is different from saying that you have to do everything on the project that you're working on, but it does mean that you're sort of ultimately responsible for the success or failure. And what that can mean is that you end up working sort of broader than your maybe nominal responsibilities to try and ease through aspects that are a little bit outside of what you care about. As an example, my main focus these days is on our databases team and on our storage team. But that doesn't mean that I just spend all day working on databases or on queries. It also means that I have to understand how people are consuming the databases that we offer and the APIs that we offer and the libraries that we offer, and how that integrates with the rest of the application. And changes can often span kind of broadly throughout the stack. And so one thing that's always been really important to us is this idea that individuals are kind of responsible for the entirety of what they work on. I think another big piece has been this idea that we want to really rigorously kind of understand the problems that we're trying to solve from the ground up. We have something of a skepticism for common wisdom as a general rule. Not that we throw it out necessarily, but that we really want to make sure that all of the assumptions that are kind of built into common wisdom still make sense for us. We talk about it as designing from first principles. And this is something that's sort of pretty deeply integrated throughout all of Stripe. We like to talk about how Stripe itself is kind of this sort of challenging the assumption of what has to happen in order to process payments.
And that's really important, not only because there is such a herd mentality in engineering, but because the surface area of options that you could potentially explore, for example, external vendors, SaaS vendors for developers, the surface area of these is growing rapidly, and you should constantly be questioning assumptions. Should we do X? Should we build X? Should we buy X? You should be constantly questioning how should we do things.
And I think it often turns out to be the case that there are ways in which the problems that Stripe is trying to solve, are different from the problems that other tech companies might be trying to solve. And so the right solution for us may be different.
Okay, go into that into more detail.
I think the biggest way that we've run into this is the way that we think about reliability and availability and latency and performance, and kind of the different ways in which you tend to evaluate these things. For us, reliability is kind of fundamentally key. And I think there are lots of other companies who will also say that, but I think we cared about reliability at an earlier stage of our company than other people do. Everybody eventually cares about it, right? Like at some point if Facebook or Twitter goes down, it becomes a big deal regardless. But there's a threshold at which that happens. There's a threshold at which it becomes problematic. And for us, I think that threshold was earlier than a lot of companies because the functioning and the availability of Stripe is so critical to the livelihoods of our users. On the other hand, performance is something that we've historically cared a little bit less about. And I think it actually turns out that was a little bit mistaken of us. But our assumption for a very long time was that if if the thing that we are doing is charging people's credit cards, there's a fundamental floor to how fast that can be, because the credit card networks, as it turns out, are not fast. If we need to talk to the card networks, there's a minimum latency, like absolute best case on a really good day of about 500 milliseconds.
Right. Realistically,
it's a lot higher. It's usually closer to a second.
So can you do stuff concurrently while you're calling out to them?
We can do some stuff concurrently, but fundamentally, if that's the component that dominates our latency, it doesn't matter if everything else takes 1 millisecond or 10 milliseconds or even 100 milliseconds. We can afford to spend a little bit more time.
Oh, so you're just talking about the relative user experience, like the user experience of Stripe with its 10 millisecond latency and the 500 milliseconds from a bank or something, relative to this, if Stripe was 15 milliseconds or 30 milliseconds, it doesn't really matter.
And in particular, what that means is that latency was not the thing that it made sense for us to focus on in a lot of cases, which I think is very different from a lot of other tech companies. For a lot of people, latency is really, really key. Whereas for us, it's kind of a fundamental thing that we can't really get around.
Sure.
And so for us, it made sense to optimize other things than latency, up to a point, obviously. But so those kinds of things mean that the focus of how we approach engineering ends up being different, because the metrics that we care about are different.
The reliability point reminds me of an anecdote from when they were building Amazon S3, the storage service. The engineers came to Bezos at one point, the CEO of Amazon, and they said, okay, we've got the V1 built. And Bezos asked them some questions, does some stress tests on it, and basically says this is not ready for prime time at all, because if we get any sort of traffic, it's going to fall over. And the engineers were saying, that's a good problem to have. It's totally okay, because that would mean we have lots of traffic. And his response was, no, that would be a failure because we would lose trust in that scenario. So when you're building a core building block that other people are building on top of, you actually can't take this minimum viable product approach.
Yeah, I think there's something that's fundamentally true there for a lot of B2B services in general, and maybe often less there for B2C type things. So I think other companies that are also targeting other businesses have similar concerns. We've always felt that ours, because it's so fundamentally tied to the success of the business, or the existence of the business even, we've always felt internally like that kind of gives it a little bit of extra pressure too.
Can you talk more about the Stripe service level agreement, the SLA that you have with users, where you make certain guarantees about how long the latency of a particular request will be?
Our numbers on that point have kind of moved a little bit over time. But for the most part, our assumption is that consumers are fairly tolerant of credit card transactions being kind of slow.
Yeah.
I think the kind of worst case unacceptable number that we tend to think of is in the 5-second range.
I interviewed Corey Watson, who works on observability at Stripe. How does observability factor into your decisions as you're building infrastructure at Stripe?
Corey's done some really amazing work here on observability in terms of making it something that I think everybody thinks about on an ongoing basis. I think it's really pushed us to be a lot more data focused on kind of a core infrastructure level, right? People talk about being data focused for business decisions and stuff like that, but the way in which observability, I think, has changed the way that Stripe works has a lot to do with the kind of the really nuts and bolts, right? When I'm thinking about, like I mentioned, I spend a lot of time these days on our database layer. When I'm thinking about how I want to change something or whether or not I need to figure out how to support a given access pattern, a lot of the work on observability has given me the ability to actually answer that question, right? I can say, are people making this type of query, rather, or what QPS do I need to support, or where is my traffic coming from? And in the past, I think we would have made that decision based on gut feel or intuition. Having data is really, really essential to being able to answer those questions. I probably use our observability stack, honestly, at least as much. I probably spend at least as much time using our observability tools as I do actually writing code.
Have you had any interesting debugging experiences with tail latency?
That definitely comes up. We see, I think, a lot of there's a lot of ways in which tail latency can come into play. Some of them are kind of unavoidable, and some of them aren't. The unavoidable kind, the one that I can think of off the top of my head, is that I mentioned the credit card networks are slow, but it turns out that in many cases it can be dependent on the specific bank that issued the credit card. We'll see cases where certain countries or a set of issuers from certain countries will take significantly longer, 10 to 15 seconds to respond to a request. And so we have to
accommodate that.
We have to accommodate that. We have to understand that it's going to happen. We have to kind of build it into our models. So I think that's kind of one way in which it pops up.
Interesting. How do you think about build versus buy decisions?
I think they're really hard. That's mostly how I think about them.
Yeah.
I think in some sense we've gotten better about this over time. I think we used to have a really bad problem with not being willing to buy solutions to problems. Yeah, I think historically, it's very easy to say, I have this one narrow need that this pre-existing piece of software doesn't meet, and therefore the solution is that I'm going to solve the problem myself, because it's only going to be a couple hundred lines of code. I think we made that decision.
And hours of maintenance.
Well, it doesn't seem like that at the start.
Exactly. That's my point.
So I think there have been cases where we've made that decision and probably did so incorrectly. We've gotten a lot better about it, about sort of taking existing solutions that mostly fit our needs and either figuring out ways to change what our requirements are, or kind of just dealing with those edges and trying to find ways that solve kind of the narrower problems.
Can you go into more detail? Like, I'm just very curious about. I think when I was talking to Corey about this, he just said, we should buy when. A lot of the companies I talk to say, basically, if you can buy, you should buy. Like, just always buy. Other people will say sometimes you should build if it's
part of your core competencies.
Mission critical. But like outsource whenever possible.
Yeah.
I don't know.
It turns out to be really hard to define what is mission critical. I think what we found over time is that, so one example I think is that we're in the process of trying to roll out Kafka more aggressively.
Yeah.
For some of our asynchronous task workers.
Certainly.
And one of the things that's challenging about Kafka right now is that if you're not writing code in the JVM, it's pretty hard to interact with.
Yeah.
Which we mostly are not. And so when we looked at how we wanted to allow our Ruby clients to say publish to Kafka, we sort of considered several different options. One of which was we would write our own thing that, our own library, or a sort of a helper daemon that could speak the protocol. So we ended up adopting a piece of software from Mailgun, actually, called Pixie, which is a helper daemon, open source piece of software that's a helper daemon that lets you post to this daemon over HTTP as a way to publish messages rather than having to talk to the Kafka protocol directly.
Oh.
So I think like people talk about build versus buy as a spend money versus, but I think it's also adopting open source software.
Right.
I think it's a lot broader than just like, do you pay a vendor for a solution?
Absolutely. So you also touched on an interesting point, the JVM interop. That's something that I have conversations with people about in the machine learning community, where they talk about it's kind of a struggle to interop between your Python libraries where you write these machine learning models and the JVM code where you have your Hadoop stuff running. Do you have any similar problems on that front?
This is definitely something that comes up. I think the machine learning side of things in particular is not something that I have as much familiarity with.
Okay.
But
it's fine. The next interview I can.
Yeah.
Perfect.
Yeah. Harass Michael about it.
Yeah.
We do run into cases where there are packages in the JVM ecosystem that we want to take advantage of, because there are a lot of really strong packages in the JVM ecosystem. That's, I think, one area where we have started to use a little bit more kind of service breakdown and service boundaries as a way to kind of get that benefit. So one example is that there's a package from Twitter called Hummingbird, which allows you to do streaming computations using a combination of real-time accumulation and Hadoop-based batch accumulation. And then you kind of sort of sometimes referred to as Lambda architecture. The idea is that you sort of do this running accumulation during the day, and then you sort of true it up at night. We use this, for example, if you go to the Stripe dashboard, we'll show you like some charts about how many charges you have and how many customers you have, and those are all powered by a Hummingbird-based system. But in order to access that, we needed to sort of stick an API on the front of it so that our Ruby code could talk to it and access that data. That's mostly been our strategy for those types of problems.
I saw you give a talk about how PCI compliance affects your infrastructure decisions at Stripe. This might sound like a terribly boring topic for some people, but it's actually pretty interesting, and it affects a lot of different businesses. Can you explain how PCI compliance affects your infrastructure decisions, and I guess what PCI compliance is?
Sure. So PCI, or the payment card industry data security standard, is the industry-generated set of rules for handling credit card numbers and other sensitive credit card-related information securely. It's not a legal framework. It's not legally mandated, but it's the card brands themselves got together and said, this is what we think it means to handle information in a secure way. It has a lot of detailed recommendations or requirements about what it means for things to be secure. It goes into a fair amount of detail about things like network isolation, cryptography requirements, who's allowed to access information, what your processes have to look like. It's a very involved set of requirements, which I think ultimately has actually proven to mostly be a good thing. And that I think that if you talk to anyone who's been through a PCI audit, they will tell you that they came out more secure afterwards than they were beforehand. But it is also very prescriptive about how you need to solve these types of problems. And it's prescriptive in a way that may not make sense for the organization as a whole. There are some things, both because there are different levels of security for different types of information, and maybe the way in which you handle credit card numbers is different from the ways in which you handle total volume numbers, or business metrics, or even other types of personally identifiable information. The standards may be different. The things you want to do may be different. And the ways you use that information are different too. And so for us, when we looked at PCI, we didn't feel like we wanted PCI to impact Stripe's organization as a whole. One of the things about PCI is that it can be somewhat viral, and that if you touch credit card numbers, you need to be compliant with PCI. If you touch things that touch credit card numbers, you may also need to be in scope for PCI. And so the scope of it can balloon if you're not careful. And so we wanted to make sure that PCI, obviously we wanted to be compliant with PCI for the sensitive information we were storing, but maybe the requirements of PCI didn't make sense for other aspects of Stripe. And so what we ended up doing is we built sort of a fairly thin shell around the API that's responsible for PCI compliance. And what it does is it takes incoming API requests, which contain PCI sensitive information, and it strips that information out and replaces it with placeholders. So maybe instead of having an actual credit card number, you have a unique identifier for the credit card number, which isn't actually the card number itself. And it passes that request on to the rest of Stripe's infrastructure. And now, by virtue of having removed the card number and the sort of the other sensitive information, it's no longer sensitive, and you no longer need to accommodate PCI scope in order to process that information.
Your application sits on layers of dynamic infrastructure and supporting services. Datadog brings you visibility into every part of your infrastructure, plus APM for monitoring your application's performance. Dashboarding, collaboration tools, and alerts let you develop your own workflow for observability and incident response. Datadog integrates seamlessly with all of your apps and systems, from Slack to Amazon Web Services, so you can get visibility in minutes. Go to softwareengineeringdaily.com/Datadog to get started with Datadog and get a free t-shirt. With full observability, distributed tracing, and customizable visualizations, Datadog is loved and trusted by thousands of enterprises, including Salesforce, PagerDuty, and Zendesk. If you haven't tried Datadog at your company or on your side project, go to softwareengineeringdaily.com/Datadog to support Software Engineering Daily and get a free t-shirt. Our deepest thanks to Datadog for being a new sponsor of Software Engineering Daily. It is only with the help of sponsors like you that this show is successful. So thanks again.
Yeah, I think in general, this idea of trying to figure out where your boundaries are is really useful in terms of protecting against scope creep and protecting against other kinds of problems like that.
Yeah, maybe you have no insight on this, but do you know can you do similar things with HIPAA compliance? Because I imagine if you're trying to anonymize medical data, it's probably much more difficult to do that. Like if you're anonymizing credit card data, it's a pretty well-formed problem. If you're trying to anonymize HIPAA compliant data, it's like, okay, this person has, like if you have a patient description, this person has a distinct pattern of hair across their face, and like this is a medically worrying thing. If they're the only person in the world that has that attribute, then you have not successfully anonymized it. And have you had any interesting conversations with people about HIPAA compliance?
Fortunately, that hasn't really come up for us.
Yet.
HIPAA compliance is much more challenging than PCI in a lot of ways.
Yeah.
It's not something that I have a ton of experience with.
Explain how you do service discovery at Stripe.
We do have kind of some maybe microservice architecture, you might call it. But there are kind of distinct components that scale up and down independently, and that we need to be able to talk to.
Sure.
For a while, we solved this the dumbest way possible, which was config files that were generated by Puppet that we would run every time we needed to update the set of hosts. And unsurprisingly, that doesn't work especially well. And so we started looking for a solution that would be a little bit more flexible and a little bit more dynamic. And we came upon Consul because we just really liked the interface that they had built around it. Like the Consul has this support for doing DNS lookups as a way of service discovery, which is kind of cute. And the way that it supports registration and checks and monitoring the state of different services, the gossip-based availability tracking, all those things sort of lined up with what we wanted. And so we started rolling it out, and what we found once we rolled it out is that intermittently we would run into some issues with Consul. And there were some early bugs in particular in the Raft implementation, or possibly the stuff around the Raft implementation, that would cause Consul to lose cluster quorum. It would stop having a leader. And I think this was somewhat compounded by, at the time, we were still using EC2 Classic, and we ran into what I believe were some networking issues at the same time that basically caused that to compound. And what would happen is that whenever Consul would lose the leadership in the cluster, it would get into the state where it was stuck doing leader elections forever, and it can never actually resolve one. And if you talk to the Consul API or the Consul DNS interface, when there is no cluster leader, it can't answer queries anymore, because queries always go to the leader by default. It biases towards consistency and over availability in the default configuration.
Sure.
And what we realized is that this isn't actually something that we want. You don't want the availability of your API to be tied to the availability of
You want an AP system. I mean, I've heard this time and time again from quote-unquote real-time applications. Like same conversation when I talk to Uber people. Yeah, we want an AP system.
Yeah, you build in a dependency on a CP system, and you realize that As soon as you hit the P and you no longer have the A, nothing good happens. And so what we ended up doing is we decided that we wanted to take this kind of CP system and turn it into an AP system for us. And the way that we did that was caching. And basically what we did is we, instead of using console itself to handle lookups, we took the entire console database and dumped it out to a service that we could run reliably and sort of independently of console's consistency. And what we ended up doing in particular is that we use console template to generate a DNS zone file. And we serve up something that is functionally identical to console's DNS interface, but has no runtime dependence on console itself.
Do you use any other HashiCorp products?
We started using Terraform for some of our infrastructure management pieces where we didn't necessarily have great in-house tooling, which is mostly how we solved this problem prior to Terraform. And so we started using it for managing certain aspects of our infrastructure, and we think we're probably going to start using it more over time.
Could you talk about the infrastructure challenges that you're dealing with at the database layer today at Stripe?
Yeah, so the main thing that we've been focused on recently is trying to detect problems before they happen. And what that mostly means is reducing the scope of database operations that we support. Databases, as it turns out, are really cool at giving you a lot of power really early on in development. When you start developing a piece of software, it's the most powerful component in your application. It probably is for a long time.
Yeah.
But at some point, the database stops, your application scales a lot better than your database does.
Right.
And so the idea that you can push all of this power and flexibility and expressiveness into the database starts becoming problematic.
Yeah.
And so what we've been looking to do is find ways to pare back the interface that we're exposing to developers, kind of limit some of the more dangerous operations, and try and make the things that people do with the database more fundamentally safe. So that means things like make sure that you have a covering index for your query. Because databases don't enforce that, right? You can query whatever you want, and the database will figure out whether or not it can use an index. But it turns out that at some point, running queries that don't have a covering index is just doesn't end well.
Sure.
When you run database queries, databases will try to use indexes in order to serve them faster, right?
Yeah.
It's effectively a fast lookup table.
Sure.
And if there is an index that sort of corresponds to the information that you're querying for, answering that query becomes much faster. And so that's a covering index.
So meaning a covering index, you explicitly specify what index this query should use? Or you just have to have one that is either explicit or implicit?
We're not doing that yet, but that's something that we're considering. If you look at one of the...
Seems like good policy.
If you can pull it off, I think it's...
Yeah, you can pull it off.
I think one of my examples here that I've kind of gone back to is if you look at the way that DynamoDB works, it actually has this requirement. If you want to query on an index, you have to specify what that index is, specify the point in the index that you want to query from, and you kind of separate. If you look at the way that queries execute under sort of a fairly simple model, you can kind of break the query down into a scan over an index and then some kind of like subsequent filtering or sorting and stuff like that. And so first of all, they don't support any sort of sorting that isn't explicitly in the index, which that sounds super cool. I would like that. And they require that you separate those two components. So like I'm scanning this index. I want you to start at this point in my kind of ordered list that is the index. And I want you to kind of keep going until I say stop and maybe apply some kind of secondary filter on the data that comes out of that. And the interface can be a little bit awkward to use. And I think that's one thing that I don't have a great answer for yet, is how do you make it a little bit more fluid. But the idea of the thing that's especially valuable about this is that it makes the execution of your queries really predictable. You know how they're going to execute. You know how much data they're going to pull. You know whether there's an expensive operation that's sort of happening independent of the data that you're reading off disk. And you can reason a lot more effectively about what's going to happen.
What are the opportunities for cost savings in your infrastructure?
I think the opportunities that we tend to look to are around more efficient usage. It's, trying to bin pack our services so that they have less wasted infrastructure in some sense, right? Like an instance that's sitting around, like if you run a service that's sitting around on an instance that's mostly idle, in some sense that's wasted infrastructure. And so I think that's one opportunity, is figuring out how to do that more effectively. I think another, again, because I tend to be focused on the databases side these days, is finding ways to downgrade your storage, finding ways to take data that's like online databases tend to be sort of the most expensive form of storage, finding ways to take data and either move it into cheaper forms of storage like S3, or support some kind of bulk access or things like that. And I think the last thing is obviously figuring out ways to make the infrastructure more elastic to adapt to load, which is, I think, challenging for us because our load patterns, our highest load patterns tend to be hard to predict. Obviously, there's the kind of gradual up and down of day to day or season to season, but one of the biggest risks for us from a load management perspective is things like flash sales, where somebody starts selling tickets to a concert at a limited supply, and they all drop at some time, and everybody comes to get them at once. It's fairly hard for us to predict those types of load patterns, and often the worst tend to be spiky enough that you can't just kind of smooth them into the long tail, right? And so being able to scale our infrastructure up and down for us, one of the biggest challenges is figuring out how to do it in a way that we can still accommodate those kinds of unexpected load spikes. We have not really looked at Lambda. For application uses, we mostly use it as an infrastructure tool for helping.
You do use it?
We do use Lambda.
Oh.
But only in fairly limited context. We use it for things like some kind of infrastructure cleanup management type pieces, and a little bit of monitoring.
Is that because those things are just totally stateless?
Yeah, pretty much.
Okay.
Because the big dream would obviously be to have everything in AWS Lambda. It's super cheap. It has auto-scaling properties.
I think there's a couple challenges with that. One is obviously that like Lambda is not a great development environment.
Yeah.
I think I think like yet. And it's clear that they're working on that. They have Python support now. But in general, the Lambda environment is not the way that I want to be writing code yet. And I think the other, though, is that I'm actually, in general, really loath to give up on visibility into that kind of responsiveness. And in particular, I don't know that Lambda necessarily has the responsiveness and scaling to accommodate that kind of thing. I haven't observed this directly, but my understanding is that the ability of Lambda to scale up and result to load is a little bit laggy. And so I think that if you were dependent on Lambda to accommodate really big spikes in load that were very transient, I'm not sure that it could actually handle that.
Evan, thanks for coming on Software Engineering Daily. This has been a great, wide-ranging conversation about Stripe's infrastructure.
Thanks for having me. This has been a lot of fun.
A few quick announcements before we go. Software Engineering Daily is conducting our annual listener survey, which is available on softwareengineeringdaily.com. You can click on the survey link. The survey really helps us understand our listeners and gives us data that we can show to advertisers that help get us better sponsorship deals. Also, the Software Engineering Daily community has started working on MinerRanker. This is an open source newsfeed platform. We are trying to democratize the idea of a newsfeed so that the only newsfeeds in town are not necessarily Twitter or Facebook or any other centralized newsfeed. We'd like to make it possible for anybody to make a newsfeed. So you can check out the MinerRanker project at minerranker.com. You can check out an implementation of MinerRanker at softwaredaily.com. You can find links to all of this stuff at softwareengineeringdaily.com. There you can also find a link to join our Slack group, to follow us on Meetup for future meetups, and other information. So thanks again for listening.